Okay, so you could be given a question that is a binomial, which means it has how many terms? And then you have to decide, okay, how am I going to factor this? What are some options of factoring a binomial? If it's what? Yep. Okay, so you have to look and see, is it a difference of squares? If it is, then you can factor it that way. You also always need to figure out if there is a greatest common factor. Okay, so those are the only two ways you can factor a binomial. Find the greatest common factor. If that's possible, figure out if it's a difference of squares. Maybe you find the greatest common factor and then you factor it and then you realize, oh, now I have a difference of squares. You can factor it again. So let's do an example. Negative, let's factor this. So this is a binomial. I'm going to look at it and I'm going to say, okay, is this a difference of squares? Is 18 a perfect square? No. Okay, so I know automatically, okay, I can't do difference of squares, and I also could even just look at the sign. It's separated by addition. It's not a difference of squares. So the only other option is find the greatest common factor. That's it. Okay, so we've done this a million times. What is the greatest common factor of negative 18x to the power of 4 and 32x to the power of 2? The greatest factor that goes into 18 and 32 is 2. 4 does not go into 18. 6 does not go into 32. It has to be a number that goes into both of them evenly. So they both can be divided by negative 2. Because it starts with a negative, I'm going to factor out the negative. And what about the variables? What's a common factor that's the variable term? X to the power of 2. We pick the lowest degree. If I go any higher than that, it's going to turn into a negative, which is not what we want. Okay, so how would I write this in factored form? Negative 2x squared. Yep. Bracket 9. Yep. Plus or minus. It's a positive divided by a negative. Yep. How many times does 2 go into 32? 16. Am I done? No. I found the greatest common factor, but now you have to check, can I still factor? What type of binomial is that? So we have the negative 2x squared. I can't do anything with that, but I can factor this more. So I'll put that in a different color. It's a difference of squares. Square root of the first term. This, what's the square root of this? 3 and x. And then the square root of the last term, 4. And it's a difference of squares, so one has to be positive and one has to be negative. Okay, so you'll be given questions where they are trinomials. A trinomial has to have 3 terms. What are the different types of trinomials you've learned about? Okay, we've learned about a perfect square trinomial. So you can look at it and say, okay, is the first term a perfect square? Is the last term a perfect square? If it is, then you can use that method of factoring. If it's not, what are other types of trinomials that you've learned how to factor? X squared plus bx plus c, where a is equal to 1. Okay, so if it's a trinomial that where a is 1, then you can use the product sum method, and we'll do some examples. Or if it's a trinomial where a is not equal to 1, then you can use that method as well. We'll go over that one as well. So if the coefficient of x squared is not 1, if it's anything greater than 1. You can always check to see if there's a greatest common factor, because just like you did on your quiz, sometimes you have to find the greatest common factor first and then factor it further, right? So always check to see if there's a greatest common factor. So let's do this one as an example. Okay, so if I give you the question negative 8x squared plus 24x minus 18, and I ask you to factor this, is it a perfect square trinomial? Is 8 a perfect square? Yes or no? No. So I know I can't use that method. Is it a trinomial where a is equal to 1? No. Now before we know that a is not equal to 1, but before we do that, let's find the greatest common factor because it looks like there is one. If there's a greatest common factor, do that first. What is it? What's the greatest common factor? Negative what? Negative 2. All of these can be divided by negative 2. So we'll rewrite this as negative 2, and then what's going to be inside the bracket? 4, and then I have x squared. Positive 24 divided by negative 2. Negative 12x, and then a negative divided by a negative is... Now how would you factor? You can still factor this. How would you do it? Yeah, so we look here and we say, okay, we have a perfect square trinomial inside the bracket, so I have to keep this negative 2, and this is a perfect square trinomial, so how would I write that in factored form? The square root of the first term is what, Ridge? 2x, and the square root of the last term? What's the square root of the last term? 3. Perfect square trinomial, you always make, what do you do with the signs? Middle term, so they're both negative in this case. How would I write that in fully factored form, Aisha? And then squared. Okay, so this is the answer, fully factored. Another example, it's a trinomial. This is still a trinomial. Is it a perfect square trinomial? No. Does it have a greatest common factor? No. So we're going to use a method where we multiply, and I did this on Friday when a lot of you were away. A is not 1, so I have to find two numbers that multiply together to give me A times C. So what's 2 times 15? Positive 30, and adds up to B, which is positive 13. Okay, so positive 3 times positive 10 is 30, and if I add those up, I get 13, and this is where you have to figure out what I'm decomposing this. Would I put the 3 with the 2, or would I put the 3 with the 15? Which one will it have a common factor with? The 15. So I'm going to rewrite this as 2m squared, and I'll put the 10 with the 2. So we're breaking this apart. Plus 10m plus 3m plus 15. I would put the 10 with the 2 because you're grouping them together. I can factor this together, and then I can factor that together. Okay? So now I'm going to write this in factored form. What's the greatest common factor of 2m squared and 10m? 2m. 2m squared divided by 2m is, and then 10m squared divided by 2m is plus 5. Okay, this is, and then what? What's the common factor of 3m and 15? Divide by 3, divide by 3. So plus 3. What's 3 divided by 3? Plus. And how would I write it in factored form? Final answer, Abisha? M plus 5. Good. Okay? We ended up with 4 terms, and we decomposed it. We grouped them together. Okay, so if it's not a binomial and it's not a trinomial, it means it has 4 more terms. Shh. And all you're going to do is find the greatest common factor or decomposition, the grouping strategy, grouping the terms together like we just did. Right? We just did it on the other example. We ended up with 4 terms, right? So that's the last method. So I'll give you an example. This one has 4 terms. Can you start by finding the greatest common factor? Do all 4 terms have x in common? No? No, the last term doesn't have an x. Do all 4 terms have a y in common?
Yeah.
What's the lowest degree?
Y.
So that all of these can just be divided by y. That's it. So rewrite this and factor out the y. What are you left with? What's x to the power of 5y divided by y? That cancels out. What am I left with? Plus, I'll let you guys, x squared y squared, because 3 take away 1 is 2, minus x cubed, and then y, yep, and then the last term is minus what, Miller? Y to the power of 4. Okay. Now you have 1, 2, 3, 4 terms. We're going to decompose it. Let's factor these together, and then let's factor these together. So I still have this y. What's the greatest common factor of x to the power of 5? This, and then x squared, y squared. What can both of these be divided by? X squared, yep. So I'd write it as, I'm going to use this bracket, x squared. What am I left with? X to the power of 3 plus y squared. And then I'm finding the greatest common factor of the last two terms. I'm going to start with a negative. What can x cubed, y squared, and y to the power of 4 be divided by? Y squared, good. So what am I left with? Yep, x to the power of 3 plus, sorry, it's negative, plus y to the power of 2. We have two terms that are the same, right? So we have y, and then what are my two terms? We have x squared minus y squared, and I have x to the power of 3 plus y squared. Am I done?
No.
I have two terms. I have a binomial and I have another binomial. When you have binomials, what do you look for? You look for a greatest common factor, and you look for a...
Difference of squares.
Are any of those difference of squares?
Yes.
So, factor the difference of squares. This is a difference of squares. So, two things that multiply together. I cannot factor this anymore. So I'm going to leave that. But this is a difference of squares. So how do you factor a difference of squares, right? The first square root of the first term, which is x, and the square root of the last term. And the signs have to be positive and negative.